today, all we're going to talk about is how to check your answer to a systems of equations, okay? Checking your answer, let's say I gave you something like this, and I said, tell if, or maybe not even tell, how about prove or show? Show that the given solution, well, actually, I shouldn't even say solution. Given coordinate is a solution
Wait, is this a problem?
to the system.
No,
This is the instructions for the problem I'm about to do to the system. So show that the given chord is a solution to the system.
my eraser's broken.
And I would say, I'm going to give you, let's see, let's do this one. Y equals 6x minus 11 and negative 2x minus 3y is equal to negative 7. And the point is, let me think, 2, 1. All right?
It's negative 4 minus.
Okay, wait, just hang on. What do you mean negative 4? It says negative 2x.
Yeah.
Okay, yeah, but just hang on. So let's just think about what they're asking. Show that the given coordinate. What is a coordinate?
The point on the line.
A point. What is a coordinate written as? What is a coordinate? Yes, Skylar.
A point
Wait,
where
somebody's talking. I don't know.
point where two numbers meet on x, y axis.
So what's that noise? Is that you? Okay.
Sorry.
Sorry, this is a video, so let's be aware of that. Yeah, say it again.
It's
Skylar.
a point where two numbers meet on an x, y axis.
It's a point where two numbers meet on an xy axis. So if I was just using variables, what would be the variables in a coordinate point? X and y. Which one comes first? X, comma, y, right? Does everybody agree with me? That is a coordinate. Every single coordinate that's ever been written that has two numbers in it, separated by a comma. The first number is the x, and the second number is the y. Is that clear? Does everybody get that? All right. Yes.
When I was in 3rd grade, I used to think that the y equals x. So technically, there is some sort of coordinate written with the y before the x.
Yes,
But it didn't make sense.
it's right. Doesn't make sense.
It's
does it?
wrong,
It's
Zane.
wrong, Zane. Okay.
Incorrect.
So
Zane, know your alphabet.
So let's just do this for a second. I'm going to put this underneath this coordinate. I'm going to put an x, comma, y. Now, I think you guys can tell that that means x, if this were a solution, x would be 2, and y, what other color do I have? Y would be 1. Do you guys agree with me?
Yes.
Okay, so therefore, what I can do is I can say if 2 comma 1 is a solution to this system, then I could plug in, wherever it says y, I could plug in the 1. And wherever it says x, I could plug in the 2. Right? I'm substituting, instead of x, I'm substituting the 2 in for this, and the y in for this. And let's say I come out with something that says 7 equals 7. I don't know if that's what I'm going to come out with, but let's say I did.
Yay, it's right.
Is that true? Does 7 equal 7?
No.
Then it is a solution to that equation. Does that mean I'm done? No,
Yes.
because I need to know if it is a solution to both equations.
Is it?
So then I would plug it in, when it says x here, I'd plug the 2 in here, and I'd plug the 1 in where it says y, and see if that comes out true. But what if it came out, the second one came out as 14 equals 13?
Totally.
Yeah.
What?
That's incorrect.
That is incorrect, right? Therefore, that would not be the solution to the second equation, if that were the case. Now let's try it.
I don't.
Let's actually do it.
The first
So I'm going to erase this, let's just try it. We got y, I'm gonna rewrite the equation over here. Y equals 6x minus 11. I know x is 2 and y is 1. So y is 1 equals 6 times 2 minus 11. You guys see what I'm doing?
Yeah.
All I'm just substituting them in. And I want to see if I get a true statement, a true mathematical statement. Skylar, do you see what I'm doing?
Yeah.
Okay. All right, so I've got 1 is equal to 12, 2 times 6 is 12, minus 11. That means 1 is equal to 1. Is that true?
Yes.
Yes! So that is a solution to this equation. But I don't know yet if it's a solution to the system, because the system, like a stereo system or anything, has more than one thing. I've got to find the other equation. I've got to substitute it in. So once it works, I put a check. And that's my little thing that tells me this checks, it works. Okay? And then I'm going to rewrite the next equation. So I've got negative 2x minus 3y equals negative 7. And so x is 2, so I'm going to write minus 2 parenthesis 2 minus 3 parenthesis 1 equals minus 7. Negative 2 times 2 is negative 4. Negative 3 times 1 is negative 3 equals negative 7. Does negative 4 minus 3, is that negative 7?
Yeah.
Negative 7 is equal to negative 7. It checks, it works, that is true as well. Yes, question?
What if the solution isn't correct? Would you have to resolve the original problem?
No, in this case, all it's saying, show that the given coordinate is a solution to the system. In this case, we just showed it. We checked it. We plugged it into this one and we checked it and said yes and yes. Now, if this came out to be 11 equals negative 7, then I would say this is not, the given coordinate is not a solution to the system.
Would you have to like write it out like that? Like the given coordinate is not a solution to the system. Or
You
just
could
write
say it is not a solution. You can be
Could you
creative.
say no solution?
No, because there is a solution to every system.
You just don't.
It's just that that isn't the solution.
Could you put
2
not
comma 1
solution?
is not the solution.
Could you write not solution? Could you just put
Sure.
an X over it and then put a check?
All right, so does that make sense? You get it? It's pretty easy, right? All right, let's try another one. I'll use the same same instruction.
It was a 4
Okay, we'll go to the other side. How about negative 3x plus 3y is equal to 3, and negative 5x plus y is equal to 13, and the point is negative 2 comma negative 3. Okay, so I'm asked again, same thing, show that the given coordinate, this is my given coordinate, and I know my x is what?
Yeah.
X is negative 2, right?
Yeah.
And my y is negative 3, right?
Yeah.
Okay, I'm going to use that information for both of these. So I'm going to say negative 3x plus 3y equals 3. So I'm going to, so negative 3 times negative, this is x, negative 2. I recommend that you actually plug them in like this instead of do it in your head, because it's doing in your head with negatives that gets like at least a third of the class confused, and you end up getting the wrong answer. So I suggest you plug it in like this first, and then you're less likely to make a mistake. Okay, whereas y is negative 3, so plus 3 times negative 3 equals 3. Okay, so negative 3 times negative 2 is?
Negative 6.
Negative 3 times negative 2 is?
6. It's 6.
It's
Gary, it's 6.
I heard some people say negative 6.
six.
6.
Which one is it? Is it negative 6 or 6?
Positive.
It's
Because
six.
negative times a negative is a positive.
It's positive 6, right? Negative 3 times negative 2 is positive 6.
It's 19.
Okay, what is positive 3 times negative 3?
19.
What is positive 3 times negative 3?
Negative
Negative
9.
13.
Negative 9.
Negative
This is
19.
a video, okay? right? What is 3 times, positive 3 times negative 3? Negative 9, so I'm going to write minus 9 or negative 9 equals 3. Let's try that. 6 minus 3 is?
3.
Is that right? 3? Is this right? Did I do that right?
Oh my god.
What is 6 minus 9?
3.
What
No,
is
it
6
doesn't
minus 9?
Negative 3.
It's got to be negative because you're taking a bigger number away from a littler. Is that true?
No!
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 All right, do I have to now check the other equation?
No!
Because
Why not?
it doesn't work.
It doesn't work. It's asking, is it a solution to the system? It doesn't matter if it works in the other one. If it doesn't work in the first one, I know it's not a solution to the system because the solution to the system has to be true for both of them, and it's not true for the first one. So immediately I say not a solution.
Not true.
Okay, does that make sense? You guys get it? It's really easy.
Why are we not
It-
going into the rest of the motion order problems?
Why what?
Are we gonna expand on them? Yeah, we're gonna do them later.
Oh.
He said we'll do them next week.
Do what? Oh, yeah, right. Because we haven't had any classes since the last quiz, and we have another quiz tomorrow. So it's like, you know, it's just kind of the way it is. So, does it make sense? Fist to 5. Do you guys understand this? It's really, really easy. Okay, Zane, explain to me where you're confused.
I'm kind of confused on, like, those equations come with the first set of.
Yeah, in this case, homework tonight, I'm giving you 4 of these, like this. All right, where I give you 2 equations and a point. And I'm asking just this, basically show that the given, or tell if the given coordinate is a solution to the system. And then you plug it in just like this. If it doesn't work in the first one, you don't have to go any further. And you just say it's not a solution. If it does work in the first one, you have to do the second one too,
And where do you
and
get
see if it works on that one.
Oh,
Because it says, that's the equation I got.
but what about the lower, the equation to the bottom? No, the equation to the bottom. The second equation.
This?
Yes.
What about it?
Oh, you.
I didn't do it.
Oh.
I didn't have to because this point does not work even in the first one. So remember, I'm asked if it's a solution to the system. The system is more than one equation. So it has to work on all of the equations. You see what I'm saying? So if it doesn't work on the first one, I know it doesn't matter. Even if it does work on the second one, it's not a solution to the system because it doesn't work in the first one. So I don't even have to go to the second one. But if it does work in the first one, I also have to check the second. Does that make sense? Get it? Okay, so that's that. And then that's it. That's it for the